Hello dear students, today we are going to cover the fourth chapter of the class 10 science, part 1, chapter number 4 effects of electric current, question and answers. So let's start. Exercise. Question 1. Tell the odd one out. Give proper explanation. Sub-question 1. Fuse wire, bad conductor, rubber gloves, generator. Answer. Generator, all others are concerned with safety measures. Sub-question 2. Voltmeter, ammeter, galvanometer, thermometer. Answer. Thermometer, all others are based on magnetic effect of electric current. Sub-question 3. Loudspeaker, microphone, electric motor, magnet. Answer. Magnet, all others are related to magnet effect of an electric current. Question 2. Explain the construction and working of the following. Draw a neat diagram and label it. Sub-question 1. Electric motor. Answer. A device which converts electrical energy into mechanical energy is called electric motor. Principle of working. Electric motor works on the principle that a current-carrying conductor placed in a magnetic field experiences a force. Construction. Point 1. Armature coil, rectangular loop of copper wire having resistive coating. Point 2. Strong magnet, armature coil is placed between the north pole and south pole of the magnet, such as horseshoe magnet. Point 3. Split ring, the two halves of the ring, X and Y, have a resistive coating on the inner side and conducting surface on the outer side. Point 4. Carbon brushes, two stationary carbon brushes, E and F, are connected to the outer side of the split ring. Point 5. Battery, the battery supplies the electric current to the armature coil. Working. Point 1. When the circuit is completed, the current flows in the branch above the loop from A to B through the carbon brushes E and F. Point 2. Since the direction of the magnetic field is from North Pole to South Pole, according to the Fleming's left-hand rule, a force is exerted on the branch up in downward direction and CD in upward direction. Point 3. Thus, the loop and the axle start rotating in an anticlockwise direction. Point 4. After half rotation, the current in a loop starts flowing in the direction DCBA. Point 5. Therefore, a force is exerted on the branch CD in downward direction and on the branch up in the upward direction, and the loop continues to rotate in the anticlockwise direction. Point 6. Thus, the current in the loop is reversed after each half rotation, and the loop and the axle continue to rotate in the anticlockwise direction. Continuation of the answer diagram is given directly. Sub-question 2. Electric generator, AC. Answer. A generator which converts mechanical energy into electrical energy in the form of alternating current is called AC generator. Principle of working. Point 1. Electric generators works on the principle of electromagnetic induction. Construction. Point 1. Armature coil, rectangular loop of copper wire having resistive coating. Point 2. Strong magnet, armature coil is placed between the north pole and south pole of the magnet, such as horseshoe magnet. Point 3. Slip rings, the ends of the armature are connected to conducting rings R1 and R2 which are fixed to the axle with the resistive coating in between the ring and the axle. Point 4. Carbon brushes, the stationary carbon brushes B1 and B2 are connected to a galvanometer. Point 5. Galvanometer, it detects the presence of current in the circuit. Working. Point 1. When the armature coil ABCD is rotated by external force in the magnetic field provided by strong magnets, it cuts the magnetic lines of forces. Thus, the changing magnetic field induces current in the coil. Point 2. After rotation of axle, arm up moves upwards, while arm CD moves downwards. Therefore, ABCD rotates in the clockwise direction. As per the Fleming's right-hand rule, the current is induced in the coil and flows from AB and CD. Current flows in the direction ABCD. Point 3. Current flows from B2 to B1 in the first half of the revolution in the external circuit. Point 4. After half revolution, arms up and CD exchange their positions. Due to this, the induced current flows in the direction DCBA. But arm up is in contact with B1 through slip ring and arm CD is in contact with B2. Point 5. In the second half cycle, in the external circuit, electric current flows from B1 to B2, in other words, opposite to the previous half rotation. Point 6. This repeats after every half rotation and alternating. Current is produced. Question 3. Electromagnetic induction means. Sub-question 1. Charging of an electric conductor. Sub-question 2. Production of magnetic field due to a current flowing through a coil. Sub-question 3. Generation of a current in a coil due to relative motion between the coil and the magnet. Sub-question 4. Motion of the coil around the axle in an electric motor. Answer. The correct statement is C. Generation of a current in a coil due to relative motion between the coil and the magnet. The process by which a changing magnetic field in a conductor induces a current in another conductor is called electromagnetic induction. This was first studied by the scientist Michael Faraday. Question 4. Explain the difference. AC generator and DC generator. Answer is given directly. Question 5. Which device is used to produce electricity? Describe with a neat diagram. Sub-question 1. Electric motor. Sub-question 2. Galvanometer. Sub-question 3. Electric generator, DC. Sub-question 4. Voltmeter. Answer. Sub-question 3. Electric generator, DC, the device which converts mechanical energy into electrical energy is called electric generator. Continuation of the answer. Question 6. How does the short circuit form? What is its effect? Answer. Short circuiting. Point 1. If a live wire, phase wire, and a neutral wire come in direct contact or touch each other, short circuiting takes place. Point 2. It is caused if the insulating coating of a wire is spoiled or lost, or if faulty electric appliances are used. Effects of short circuiting. Section A. During a short circuit, the resistance of the circuit becomes very small and hence huge amount of current flows through it. Section B. This produces a large amount of heat and raises the temperature. As a result, the circuit catches fire and can cause damage. Question 7. Give scientific reasons. Sub-question 1. Tungsten metal is used to make a solenoid-type coil in an electric bulb. Answer. Point 1. The electric bulb works on the principle of heating effect of electric current. Point 2. The intensity of light emitted by the filament of an electric bulb depends on the temperature of the filament. Point 3. When electric current is passed through the filament, a large amount of heat is generated and filament becomes hot, then emits light. Point 4. The melting point of tungsten is very high, 3380 degrees Celsius, so that filament can be heated to a high temperature without melting. Point 5. Hence, the filament of electric bulb is made up of tungsten. Sub-question 2. In the electric equipment producing heat, for example, iron, electric heater, boiler, toaster, etc., an alloy such as nichrome is used, not pure metals. Answer. Point 1. The appliances like iron, electric toaster, etc., works on the principle of heating effect of an electric current. Point 2. At high temperature, pure metal can get oxidized, and also pure metals have low resistivity. Point 3. An alloy such as nichrome has high resistivity and can be heated to a high temperature without undergoing oxidation. Point 4. Thus, nichrome is preferred over other pure metals and are used for making coil for devices working on heating effect of electric current. Sub-question 3. For electric power transmission, copper or aluminium wire is used. Answer. Point 1. Copper and aluminium are good conductors of electricity. Point 2. Copper and aluminium have large number of free electrons and are highly ductile metals. Point 3. They have less resistivity, due to which these metals have high conductivity. Point 4. Hence, connecting wires in the electric circuit are generally made of copper and aluminium. Sub-question 4. In practice, the unit kWh is used for the measurement of electrical energy rather than joule. Answer. Point 1. The unit of electric power, W, is a very small unit, hence 1000 W or 1 kilowatt is used in practice. Point 2. Now if 1 kilowatt power is used for 1 hour, it means 1 kilowatt times 1 H. In other words, 1 kilowatt hour energy is consumed. Point 3. Joule is the C unit for energy, which is very small, hence on commercial scale kWh is used to measure electrical energy. Question 8. Which of the statement given below correctly describes the magnetic field near a long, straight current carrying conductor? Sub-question 1. The magnetic lines of force are in a plane perpendicular to the conductor in the form of straight lines. Sub-question 2. The magnetic lines of force are parallel to the conductor on all the sides of conductor. Sub-question 3. The magnetic lines of force are perpendicular to the conductor going radially outward. Sub-question 4. The magnetic lines of force are in concentric circles with the wire as the center in a plane perpendicular to the conductor. Answer. The correct statement is section D. The magnetic lines of force are in concentric circles with the wire as the center in a plane perpendicular to the conductor. Question 9. What is a solenoid? Compare the magnetic field produced by a solenoid with the magnetic field of a bar magnet. Draw neat figures and name various components. Answer. Solenoid. Point 1. When a copper wire with a resistive coating is wound in a chain of loops, like a spring, it is called solenoid. Point 2. When an electric current is passed through a solenoid, magnetic field is produced in it. Point 3. The magnetic lines of force are similar to that of the lines of a bar magnet. Point 4. Solenoid has all properties of the field produced by a bar magnet. Continuation of the answer diagram is given directly. Point 5. One end of the coil acts as the south pole, while the other end as the north pole. Various components are: Section A, copper wire with resistive coating. Section B, battery. Section C, plug key. Question 10. Name the following diagrams and explain the concept behind them. A. Answer. Point 1. Fleming's right-hand rule. Point 2. This rule is used to find the direction of the induced current. Point 3. Stretch the thumb, the index finger and the middle finger of the right hand in such a way that they are perpendicular to each other. In this position, the thumb indicates the direction of motion of the conductor, the index finger indicates the direction of the magnetic field, and the middle finger shows the direction of the induced current. This rule is known as Fleming's right-hand rule. B. Point 1. Fleming's left-hand rule. Point 2. This rule is used to find the direction of the force on the conductor. Point 3. According to this rule, the left-hand thumb, index finger, and the middle finger are stretched such that they are perpendicular to each other. If the index finger is in the direction of the magnetic field and the middle finger points in the direction of the current, then the direction of the thumb is the direction of the force on the conductor. Question 11. Identify the figures and explain their use. A. Answer. Point 1. Cartridge fuse. Point 2. Fuse is a device which protects the appliances from excess current. B. Answer. Point 1. Miniature circuit breaker, MCB. Point 2. When the current in the circuit suddenly increases, this switch opens and current stops. C. Answer. Point 1. DC generator. Point 2. It is used to generate direct current. Question 12. Solve the following example. Sub-question 1. Heat energy is being produced in a resistance in a circuit at the rate of 100 watts. The current of 3A is flowing in the circuit. What must be the value of the resistance? Answer is given directly. Sub-question 2. Two tungsten bulbs of wattage 100 watts and 60 watts power work on 220 V potential difference. If they are connected in parallel, how much current will flow in the main conductor? Answer is given directly. Sub-question 3. Who will spend more electrical energy? 500 watts TV set in 30 minutes or 600 watts heater in 20 minutes? Answer is given directly. Continuation of the answer. Sub-question 4. An electric iron of 1100 watts is operated for 2 hours daily. What will be the electrical consumption expenses for that in the month of April? The electric company charges 5 rupees per unit of energy. Answer is given directly. Continuation of the answer.
Great video. Mom.
Yes.
I found the good channel for study.
Great. Like the video, share it to your school friends. Subscribe to it. But what's the channel's name?
Wings of Fire Academy.